An ice dam occurs when water builds up behind a blockage of ice. Ice dams form either when glacier blocks a river and forms a lake, or when ice chunks in a river are blocked by something and build up to form a dam, often called an ice jam. Glacial ice dams have historically resulted in massive outburst floods. River ice jams can cause flooding upstream during the jam, flooding downstream when the jam releases, and damage from the ice itself on structures and ships in or near the river. Ice jams on a lake or ocean occur during the spring breakup if wind-driven ice piles up along a shoreline. Glacial ice dams. The movement of a glacier may flow down a valley to a confluence where the other branch carries an unfrozen river. The glacier blocks the river, which backs up into a preglacial lake, which eventually overflows or undermines the ice dam, suddenly releasing the impounded water in a glacial lake outburst flood, also known by its Icelandic name, a Jökulárás. Some of the largest glacial floods in North American history were from Lake Agassiz. In modern times, the Hubbard Glacier regularly blocks the mouth of Russell Fjord at 60 degrees north on the coast of Alaska. A similar event takes place after irregular periods in the Perito Moreno Glacier, located in Patagonia. Roughly every 4 years the glacier forms an ice dam against the rocky coast, causing the waters of the Lago Argentino to rise. When the water pressure is too high, then the giant bridge collapses in what has become a major tourist attraction. This sequence occurred last on March 4, 2012, the previous having taken place 4 years before, in July 2008. About 13,000 years ago in North America, the Cordilleran ice sheet crept southward into the Idaho Panhandle, forming a large ice dam that blocked the mouth of the Clark Fork River, creating a massive lake 2,000 feet deep and containing more than 500 cubic miles of water. Finally, this glacial lake Missoula burst through the ice dam and exploded downstream, flowing at a rate 10 times the combined flow of all the rivers of the world. Because such ice dams can reform, these Missoula floods happened at least 59 times, carving dry falls below Grand Coulee. River ice jams. An ice blockage on a river is more often called an ice jam, but sometimes an ice dam. An ice jam is a dam on a river formed by blocks of ice. Defined by the International Association of Hydraulic Research Working Group on River Ice Hydraulics, an ice jam is a stationary accumulation of fragmented ice, a phrasal that restricts flow on a river or stream. This definition includes what some scientists call an ice dam as a bottom accumulation of anchor ice. Ice jam floods are less predictable and potentially more destructive than open water flooding and can produce much deeper and faster flooding. Ice jam floods also may occur during freezing weather, and may leave large pieces of ice behind, but they are much more localized than open water floods. Ice jams also damage an economy by causing riverside industrial facilities such as hydroelectric generating stations to shut down and to interfere with ship transport. The United States averages $125 million in losses to ice jams per year. Ice jams on rivers usually occur in the springtime as the river ice begins to break up, but may also occur in early winter during freeze-up. The breakup process is described in 3 phases: pre-breakup, breakup, and final drive. Pre-breakup usually begins with increased springtime river flow, water level, and temperatures fracturing the river ice and separating it from the shore. Changes in river height from dam releases may also affect the pre-breakup. During the breakup, the ice in areas of rapids is carried downstream as an ice flow and may jam on still frozen sections of ice on calm water or against structures in the river, such as the Honeymoon Bridge, destroyed in 1938 by an ice jam. Smaller jams may dislodge, flow downstream and form a larger jam. During the final drive, a large jam will dislodge and take out the remaining jams, clearing the river of ice in a matter of hours. Ice jams usually occur in spring, but they can happen as winter sets in when the downstream part becomes frozen first. Freeze-up jams may be larger because the ice is stronger and temperatures are continuing to cool, unlike a spring breakup when the environment is warming, but are less likely to suddenly release water. 3 types of natural ice jams can occur: a surface jam, a single layer of ice in a flow on calm water; a narrow channel, a wide channel jam; and a hanging jam, the accumulation of river ice at slow current areas which only occur during freeze-up. Ice jams also occur at sharp bends in the river, at man-made objects such as bridge piers, and at confluences. Northerly flowing rivers tend to have more ice jams because the upper, more southerly reaches thaw first and the ice gets carried downstream into the still frozen northerly part. 3 physical hazards of ice jams are: 1. The ice flow can form an ice dam and flood the areas upstream of the jam. This occurred during the 2009 Red River flood and the 2009 Alaska floods. 2. After the ice dam breaks apart, the sudden surge of water that breaks through the dam can then flood areas downstream of the jam. 3. The ice build-up and final drive may damage structures in and near the river and boats in the river. Ice jams may scour the riverbed, causing damage or benefit to wildlife habitats and possibly damage to structures in the river. Early warnings of an ice jam include using trained observers to monitor breakup conditions and ice motion detectors. The prevention of ice jams may be accomplished by weakening the ice before the breakup by cutting or drilling holes in the ice, weakening the ice by dusting it with a dark-colored sand, or controlling the timing of the breakup using icebreakers, towboats, hovercraft, or amphibious excavators. However, the movement of migratory fish is known to be related to freeze-up and breakup, so affecting ice breakup may affect fish migration. Where floods threaten human habitation, the blockage may be artificially cleared. Ice blasting using dynamite may be used, except in urban areas, as well as other mechanical means such as excavation equipment, or permanent measures such as ice control structures and flood control. Ice jams on a lake or ocean occur during the spring breakup if wind-driven ice piles up along a shoreline.